so far we've talked about all these scary anthropogenic sources of methane. Let's talk about where it can come from naturally. Well, about 200 million tons of methane is added to the atmosphere each year by natural sources, and by far the most of it is coming from wetlands. This is swamp gas, very much like what happens, same kind of processes as what happens in a rice paddy, where the standing water in the soils beneath there, where the decomposition of plant matter is happening, just produces enormous amounts of methane. Some methane comes from geologic processes like the formation of coal seams and volcanic eruptions and things like that. And some comes from wild animals. I mean, wild animals have flatulence too. But the swamp gas is certainly the major source of natural gas in the Earth's atmosphere. If you took a look at the total spectrum of emissions or total inventory of emissions globally, we find that about 35% of the methane that is getting added to the atmosphere is from natural sources, and about 2/3 of it is being from anthropogenic sources. This is why the methane levels in the Earth's atmosphere have more than doubled since the Industrial Revolution. We are responsible for most of this methane that is getting added to the Earth's atmosphere. Now, we are adding methane to the Earth's atmosphere. The Earth's atmosphere can be thought of then as a reservoir of this methane. But in general, the methane doesn't go and get stored in rocks. It doesn't in general have all these there isn't a complicated carbon cycle of methane that we're going to be worried about. And that actually turns out to be fairly good news, because there is a fairly simple pathway to get rid of methane in the Earth's atmosphere. It's a process that goes by the totally unhelpful name of oxidation. If you know anything about chemistry, what isn't oxidation? Rust and fire and respiration and combustion and all these things, they're all ways of saying oxidation too. But your book uses the term oxidation to describe this chemical reaction, which unfortunately you do need to know, because this is an understanding science Magis Core course. But in the oxidation reaction, a methane molecule is in the presence of two oxygen molecules will be oxidized into carbon dioxide and two water molecules. And that just basically means that we take the methane and we turn it into carbon dioxide using a fairly simple chemical reaction, and it's actually a fairly efficient chemical reaction. In fact, if we as a society stopped emitting methane into the atmosphere through, the natural gas delivery system and by raising cattle and so on, the oxidation process would actually return methane concentrations back to their pre-industrial levels in just like a decade or two. The methane problem is surprisingly solvable if we were willing to, give up beef, and if we were willing to give up natural gas as a source and so on. Well, I'm not so sure we're thrilled about that, but it's a surprisingly solvable question. Now, your book doesn't mention one other really important and potentially scary source of methane. I just shot you here the Wikipedia page that's labeled methane clathrate. I always have a hard time saying that word. Methane clathrate. A more common word is methane ice or methane hydrate. Methane can form an ice-like substance under a specific range of temperatures and pressures. And it turns out on Earth there's a great place to make methane ice or methane hydrate or whatever, and that is on the continental shelves where under the ocean, but before the ocean gets really deep. Under that combination of temperatures and pressures, methane forms an ice-like material, methane ice, methane hydrate, or whatever. It is methane with water, and it's a kind of a crystal type formation that stores a lot of methane. It's down deep it's on the continental shelf, so it's not like miles deep. It's a few hundred meters deep off most continents. It is, I give you a picture of it right there. It really looks like ice, okay? And it is a resource. Methane ice might actually turn out to be the single biggest fossil fuel on Earth. There's probably more energy in the form of methane ice on the bottom of the ocean than there is coal, or there is petroleum. Or shale oil, or natural gas in shale deposits, and so on. And it turns out it might even be economical to recover it and burn it. They actually use the word mine it, where they would actually somehow dredge the seafloor to recover the methane ice and bring it to the surface, and then there would have to be an industrial scale process to convert it back into methane and dry it out, get rid of all the water vapor and the ice, the liquid water and so on that's in there. Which is either wonderful or horrible, depending on how you think about it, because when you burn this methane, it's natural gas. It's going to be releasing carbon dioxide into the Earth's atmosphere. So there's a huge, wonderful source of energy that might even be economically viable, and it's everywhere, but burning it is going to be a problem. We're going to be just adding more to our greenhouse effect problem. But it gets worse. Methane ice, down there at the bottom of the ocean, depends on the water temperature being in a very narrow range that happens to be where the water temperature on the bottom of the seafloor on a continental shelf happens to tend to be. But what about if we warm the world? What if we warm the ocean? Yeah, literally just a few tenths of a degree warmer than this, methane ice converts back into methane gas, and it bubbles out of the ocean and back into the Earth's atmosphere. Suddenly you're adding enormous amounts of methane to the Earth's atmosphere. Methane's a powerful greenhouse gas, and all of a sudden you have a runaway climate catastrophe. This is thought to be part of the story of how some of the big climate catastrophes that have happened in Earth's history may have happened. It may very well be that if you can get the temperature of the ocean just warm enough that methane starts leaving the form of methane ice and becoming methane gas in the Earth's atmosphere, suddenly you have this runaway greenhouse effect where you're warming the planet, more methane ice bubbles into the Earth's atmosphere, more greenhouse gases, and you have a runaway effect until you run out of methane clathrates on the bottom of the ocean. That is a possible disaster that keeps environmental scientists up at night. Alright, before we're done with this lecture, let me just ask you 3 more quick questions here. True or false? Anthropogenic sources of methane exceed the natural sources of methane. Make a choice, get a little feedback before we move on to question 4.